And welcome back, and it is the 22nd of March, higher plus 5 a day. Let's just go straight with the first question, right? What do we have? So two solids mathematically similar. Now, as soon as I see similar, I'm thinking, is it a similar triangles one, or is it, as this one is, surface areas and volumes and lengths? Well, it's going to be the surface area, volume, length one. So I'm going to think of my length, my area, and my volume. And I've got the small one, and I've got the large one over here. Now, it will always tell me a piece of information. And it tells me the surface area of the smaller one is 42 pi. And it tells me the surface area of the larger one is 1512 pi. Now, that might seem like a horrible number. If I get my calculator out, 1512 divided by 42 is equal to, oh, there we go, is equal to 36, which means my area scale factor is 36. And the reason I feel better about that is because that means my length scale factor is a square root of that, which is 6, and my volume scale factor is a cube of 6, which is 216. What does it want me to do? So it now tells me the height of the largest side is 96. So in other words, to get from the height of the larger to the smaller, I'm going to do 96 divided by the length scale factor, which is 6, and that's just going to give me 16 centimeters. Not as bad as it looks. First question done. Next question. Right, I can see straight away this is a bounds question. Now, actually, it's worse than a bounds question, isn't it? Because it's a suitable degree of accuracy. So I'm going to have to work out W. I have to work out the maximum and minimum value I can get for W. Okay, so let's start by doing the bounds first of all. So the Y value, so looking over here, so the Y value is 1800 to 2 sig fig. So the second sig fig above is 1900, and the sig fig below is 1700, which means my range is 1750 to 1850. Then look at my R, so over here, so my R is 7.1, one decimal place, so change the first decimal place is 7.2, decimal place down is 7.0, which means the range here is 7.05, in other words the median of these numbers, to 7.15. So far so good. That'll be a couple of marks in the exam. It would have got me something. Then I need to work out the upper value of W. Well, that's going to be the cube root of the maximum value of Y divided by the smallest value of L, because divide by a smaller number leaves me with a bigger number behind, which is going to be, well, it's a cube root. So I'm going to move this down. I'm going to separate it out so you can see what I'm doing. So that's going to be the cube root of, well, the maximum value of Y is 1850, and the smallest value of L is 7.05. And that's going to give me approximately, well, I say approximately, I need to be pretty precise here. So the cube root, there's a button on your calculator, so the cube root of 1850 divided by 7.05. I'm going to write down a few. So 1.74127. And I hope I don't need anywhere near that many, but we might have to come back. And my lower bound is going to be the cube root of the lower. So it's the cube root of the lower, which is 1750. And I'm dividing that by the highest value of R, which is 7.15. So calculator out again, so cube root of, so shift cube root, 1750 divided by 7.15, which is, oh, okay, that's not too bad. I'll explain why in a second. So 1.6854, don't need any more than that. Now, that's given me the upper and lower bound of W, which means W must be between the lowest it can possibly be, this number here, and the highest it could possibly be, which is this number here. Now, W itself, if I round it, now I'm sorry, I'm going to have to go over here just so I've got space. So think about W, I'm going to go back to 1 sig fig, 2 sig fig, 3 sig fig, etc. To 1 sig fig, the upper bound is 2, and the lower bound is going to be 2 as well. 1.68 to the nearest sig fig is 2. To 2 sig fig, it's 1.7 lower and 1.7 higher. So far, so good. These numbers are the same. To 3 sig fig, it's 1.74 and 1.69. These numbers are not the same. So therefore, it's not a suitable degree of accuracy because it's different numbers. So the answer to my question is that the highest degree of accuracy, these numbers are the same, which is going to be 1.7. Not a nice question. People do not like these questions when we teach it, but nevertheless, that is the answer to that question. Next question. Okay, we're back to a bit of algebra. If you've seen my videos before, definitely a bit of a technique here. Please don't learn it as a technique, just understand how to do it. But it's kind of the same thing each time. So multiply by the denominator, which is going to give me xy minus 3y, is equal to x plus 7. Collect all my x's to the left, which is going to give me x, y minus x is equal to 3y plus 7. Then I'm going to factorise out my x's, which is y minus 1 equals 3y plus 7. Now, crucially, I've now got an x on its own, which means that x is equal to 3y plus 7 divided by y minus 1, and that is my final answer. After that last difficult, annoying question, that was not too bad. Okay, next question. Shown are two straight lines drawn on a grid. Line 2 has equation. Okay, so we have no values, which means we need to use line 2 to work out the values on the grid. If I think about line 2, what do I know? I've got a lot of space here, it doesn't matter. So for line 2, if x equals 0, y is equal to 18. And if y equals 0, well, x is equal to 9, because minus 2 times 9 is minus 18, plus 18 is 0, so x, not y, x is equal to 9. And now I need to use these numbers here to get this scale on the x and y axis. So let's do that. So look at my x value. I know my x value has to be 9, so I'm guessing these are 1. So I'm guessing that's 1, 2, 3, 4, 5, 6, 7, 8. Does work out eventually, 9. Good. My y value is 18, which actually is a horrible scale because that's in 9s, isn't it? So that's 9 and that's 18, which means it's a 9 for each square when I go vertically. So minus 9, minus 18, minus 27, wow, minus 36. So it's not nice, but I've managed to get 2 points on the curve, which means I can work out the gradient of L1. To be clear, now I'm going to have to, what I'm going to do, I'm going to do this question. So what I'm looking at, I'm going to do this question, I'm going to do that underneath. So let's just box that off for now, because I want you to be able to see what I'm doing. So for line, which one am I doing? For line 1, I know the gradient. Well, I'm going from minus 36 to 2. So in other words, I'm going up 36 and I'm going across 2. So therefore my gradient is 18. I know my gradient, so therefore it's going to be y is equal to 18x. I know the c value is 36, I can see it on the graph, so therefore my equation of line L1 is 18x minus 36. Wow, that felt like a bit of a journey to get there, but we got there. Now, answering this question here. So are they perpendicular? So this question now, so let's draw another line in just so it's slightly more sensible. Perpendicular lines is where you m1 times m2 equals minus 1. The first one had a gradient of minus 2, and the second one had a gradient of 18, and minus 2 times 18 is minus 36, which doesn't equal minus 1. So conclusion, therefore not, nice and clear, perpendicular. And wow, quite a mix of questions today. Started off okay. That second question I know nobody likes. Third question all right. That fourth question significantly harder than it looks, but well done if you got there. As ever, let me know how you did. Do like, subscribe, and I'll see you tomorrow. Thanks all.